Question 14, and we're now on to circles. When we see a circle equation, and we know this is a circle equation because I've got x squared, y squared, x's and y's, and no product term, as in x multiplied by y, the first thing I'm going to do is to complete the square for each part. So that's going to be x minus 3 in this case, all squared, because half of negative 6 is negative 3. Correction term minus 9, and then complete the square for the other part, which is going to be y plus half of 10, which is 5, all squared, and correction, and then I need the plus 9 on the end, which equals 0. I then see that 9's cancel. I can rearrange this to then give me x minus 3 all squared plus y plus 5 all squared equals 25. And again, some people choose to then write this down as 5 squared so that we can read off the next part straight away. So for the next bit, I want the coordinates of the centre. Well, this is just like finding the roots of these two brackets. That is going to be when x is equal to 3, because that will nullify the first bracket, and when x is equal to negative 5, because that would nullify the second. So there's the centre of my circle at 3, negative 5. And for the second part, I just need the radius of the circle, which here is going to be my 5. For the second part of this, I'm solving a quadratic simultaneous equation. I've got an equation of a straight line, y equals kx, and I'm going to substitute that into one of my earlier equations. Now, I'm not going to use my completed square version, because all I would end up needing to do is to expand my equation to get back down to what they gave me originally. So I'm going to start this equation from saying I've got x squared plus, now I've got y is equal to kx, so I'm going to write that down as kx all squared minus 6x plus 10 lots of kx plus 9 equals 0. So let's then continue with this. So this will give me x squared plus k squared x squared minus 6x, what's going on here, there we go, plus 10kx plus 9 is equal to 0. I'm going to tidy this up slightly and say that this is 1 plus k squared lots of x squared, and I'm going to say that this is going to be plus 10k minus 6 lots of x and plus 9 to finish. Now what do I want to find? I've got two distinct cutting points, which means that the discriminant of this equation must be greater than 0, because this quadratic equation must give me two distinct points. It must give me two x values. So I know here that the discriminant of this equation, because it's quadratic, the discriminant should be greater than 0 to give me those two possible solutions. So I want to find that delta is greater than 0, or that is that b squared minus 4ac is going to be greater than 0. Well, b here is going to be 10 minus 6, that's my value for b, so I want to square that and then take away 4 lots of 1 plus k squared multiplied by c, which is 9, and I want to find that that's greater than 0. And again, an indicator here that I'm doing the right thing is that I want to find a range of values for k, and I'm solving in an inequality, which is always going to allow me to find that range. Expanding that first bracket, I've got square twice the product, which is going to be minus 120k, square the last term, and then expanding the second bracket, that's then giving me 4 times 1 times 9, which is minus 36, and 4 times k squared, so minus 4k squared. My apologies, 4 times k squared times 9, so again that's going to be 36, so minus 36k squared, which is greater than 0. Tidying this up, the 36's cancel. 36 from 100k squared is going to leave me with 64. So I've got here 64k squareds minus 120k being greater than 0. I can see both of these divide by 8. That would give me 8k squared minus 15k is greater than 0. And factorizing that is going to give me k lots of 8k minus 15, which is greater than 0. Now I like drawing graphs at this point because it allows me to see the solutions really clearly. So the graph would go through here at k is 0, and it would go through here at 15 over 8. What would it look like? It would look like a quadratic graph. And what am I interested in? I'm interested in the points where k is greater than 0. So I'm interested in these points where the value is going to be greater than 0. So when does that happen? It happens when the value of k is less than 0, and it also happens when the value of k is greater than 15 over 8. So my final solution for this question is going to be k such that k is less than 0, and k such that k is greater than 15 over 8, and that's one set of values, so I put it in curly brackets. That's the other set of values, so I put it in curly brackets, and then I say it's the union of those two things. Potentially this is a bit extra, but we always like to make sure that we give a full and complete solution.